Oh, serious friend, today we are going to start a chapter that is ammonia. Now, we have already started this chapter, this portion we have already started. Today we are going to discuss about the fountain experiment. What happened during this fountain experiment? So this is a round bottom flux, inverted round bottom flux. Now this one narrow capillary tube has been inserted, which is dipped in a trough containing a red litmus solution. Through here a dropper is being here. With the help of this dropper, the water is being pushed into this round bottom flux, and this is being stand over a stand that is called a retort. Now this is a stand. This is a stand over which then what will happen here now? This red litmus will enter through this capillary tube, and after entering, we are just pressing this dropper here so that water will get mixed with this gas. As a result, we will get a blue fountains. Okay. Now, why? A bottle of liquid ammonia should be opened very carefully only after cooling it in ice cold water. This is high pressure inside the bottle of ammonia, and on cooling the pressure drops. This prevents sudden flushing out of gas. This is a property of ammonia. Now the dropper containing water is squeezed. A few drops of water enter the flux. Ammonia gas present in the flux dissolves in water due to high solubility. This creates a partial vacuum in the flux. Since pressure outside is higher, red litmus solution rushes up through the jet tube, emerges as a blue fountain. Ammonia gas, being basic, changes red litmus solution to blue. Now, chemical properties of ammonia. First is thermal dissociation. Now, what do you mean by thermal dissociation? Ammonia gas dissociates into nitrogen and hydrogen at a high temperature or by electric spark. This ammonia gas, this is a reversal reaction. Okay. Now, basic property. Dry ammonia is covalent molecule, so it is neutral even in liquid form. Its aqueous solution is a weak base. The basicity is due to the lone pair of electron. Say how? I am showing you the availability of this lone pair of electron. Here is the lone pair of electron. Getting? Now, aqueous solution of ammonia. What is aqueous solution of ammonia? We will call this one as NH4OH. This is the formula of aqueous solution of ammonia. Is a weak base. It dissociates partially to give hydroxyl ion. Now, ammonia plus water. What will get? Ammonium hydroxide. Now, ammonium hydroxide, this will give ammonium ion and hydroxyl ion. Now, action indicators. Moist litmus, red to blue. Then methyl orange to yellow. Then phenolphthalein colorless to pink. Getting? Now, burning of ammonia in oxygen. Ammonia is not a supporter of combustion. It extinguishes a burning spirit and does not burn in air. It burns in oxygen with a yellowish green flame. Now, say when ammonia reacts with oxygen or burns in oxygen, 2N2 plus H2O. A wide glass tube is fitted with a core carrying two tubes. Say here this is a wide fitted with two tubes. Ready? Now, now, a wide glass tube is fitted with a cord carrying two tubes, one of which reaches just near the top and another remains lower. Ammonia gas is passed through longer tube and oxygen gas through shorter tube, and lighted match is applied. Ammonia burns with yellowish green flame and produces water vapor and nitrogen. It shows that ammonia contains nitrogen and hydrogen. The reaction is irreversible and strongly exothermic. This is the reaction. Getting? Now, catalytic oxidation of ammonia. Catalytic oxidation of ammonia. Catalytic oxidation of ammonia. What do you mean with catalytic oxidation? In the presence of platinum at 800 degrees centigrade, ammonia reacts with oxygen to give nitric oxide and water vapor. Say ammonia plus 5 mol of oxygen, platinum at 800 degrees centigrade. It will give 6 molecules of water plus 4 nitric oxide plus heat. Ready? Now this 2NO plus O2 will give NO2, which is brown. Ready? Now reddish brown vapor of nitrogen dioxide is seen in the flux due to oxidation of nitric oxide. Got? The platinum catalyst continues to glow even after heating is discontinued, since catalytic oxidation of ammonia is an exothermic reaction. This is an exothermic reaction. Ammonia as a reducing agent. Now reduction of metallic oxide. Ammonia reduces heated metallic oxide to give metals, water vapor and nitrogen. Say, I'm showing you this reaction. This is ammonia and this is your copper oxide, metallic oxide. On reacting, we will get copper plus water plus nitrogen gas. This is your reddish brown. This is your black solid. Getting? Now, the black copper oxide is reduced to reddish brown copper. Similarly, ammonia reduces a heated yellow lead monoxide. When reacted with ammonia, it will give Pb plus H2O plus nitrogen. Now collection of gas. Nitrogen is collected over water in a gas jar. Apparatus is being shown in figure 9.8. The water formed is collected in a U-tube and is tested with anhydrous copper sulfate, which turns blue. This reaction proves that ammonia is made up of nitrogen and hydrogen, and therefore nitrogen hydride. Now reduction of chlorine to hydrogen chloride. When ammonia reacts with chlorine, it will give nitrogen as well as hydrogen chloride. Now 6 ammonia reacts with 6 HCl, then it will give 6 NH4Cl. Ready? Now on adding this one, 8 NH3 plus 3 Cl2, this HCl will get cancelled. Okay, this will get cancelled, then it will be N2 plus NH4Cl. Now see this, dear student, this is a reaction of chlorine to hydrogen chloride, and this is a very, very important reaction. Now when nitrogen is in excess, the yellowish green color of chlorine disappears as white fumes of ammonium chloride. Yellowish green color of chlorine, its color will get decolorizes, disappears into white color. Now when chlorine is in excess, say, then it's the product hydrogen chloride and a yellow colored highly explosive liquid nitrogen trichloride. That is what that ammonia, when reacts with chlorine, Then product will be HCl plus NCl3. Its color is what? It is highly explosive, yellow colored highly explosive liquid, nitrogen trichloride. Got? See, these reactions show that chlorine has a great affinity for hydrogen. Ammonia is a reducing agent. From this reaction we can conclude two things, that is chlorine has a great affinity towards hydrogen and ammonia is a reducing agent. Now reduction with acid. Reduction with acid. Say ammonia when reacting with HCl, then ammonium chloride. This is a solid, this is a gas, this is a gas. Now ammonia plus HNO3. This will be ammonium nitrate. This is your gas. Now when ammonia react with H2SO4, then our product is there, that is ammonium sulfate. Okay. Now these are the reactions with acid. 3 acid, HCl, HNO3 and H2SO4. Like the same, say some metallic salts. When ammonium hydroxide reacts with metallic salts such as ferrous sulfate, ammonium sulfate plus ferrous hydroxide, dirty grain, and it is insoluble in the excess of ammonium hydroxide. Now when PbCl3 reacts with ammonium hydroxide, ammonium chloride, ferric hydroxide, reddish brown and insoluble in excess NH4OH. Now this table is very important table. Dear student, you all have to practice those reactions which are given in the table. Prepare it in a nice way. Okay, from this table 2 to 3 marks questions are coming every year. Now ammonium chloride is a good example where two colorless gases react to form white solid directly. What is this? Ammonium nitrate and ammonium chloride both show thermal dissociation. Thermal dissociation means ammonium chloride on dissociating the presence of heat, ammonia plus HCl. Now ammonium nitrate. Now this reaction you see N2O plus H2O. Dear student, this is a laughing gas. Okay, aqueous solution of ammonia. Ammonia is dissolved in water to form its aqueous solution. When ammonia reacts with water, an aqueous solution is formed, that is your ammonium hydroxide. Okay, ammonium hydroxide, reaction of ammonium hydroxide with acid. Say for example HCl. And what will be the product? NH4Cl plus water. Then NH4OH plus HNO3. This will be ammonium nitrate plus water. Now ammonium hydroxide plus H2SO4, NH4 whole 2 SO4 plus water. Getting everywhere water is informed. See these reactions are equally important, dear student. Now reaction of aqueous solution of ammonia with soluble metal salts. Ammonium hydroxide, see this table, I have to explain you right now. Reaction of aqueous solution of ammonia with soluble metal salts. Aqueous solution means what? That is your ammonium hydroxide. Say metal salts such as ferrous sulfate plus NH4OH. What will the product? Ammonium sulfate plus ferrous hydroxide. And its color is what? It will be precipitate, dirty green, and which is insoluble. This is insoluble in excess of ammonium hydroxide. Like the same when ferric chloride reacts with ammonium hydroxide, then ammonium chloride plus FeOH whole 3. Its color is reddish brown. This is dirty green and this is reddish brown. Now lead nitrate, ammonium hydroxide. What will the product? Ammonium nitrate plus PbOH whole 2 then hydroxide, quite insoluble in excess, then zinc nitrate, zinc nitrate, zinc nitrate plus ammonium hydroxide. What was the product? Ammonium nitrate plus zinc hydroxide. White gelatinous, soluble in excess, NH4OH. Now the last one, copper sulfate plus ammonium hydroxide. Ammonium sulfate plus copper hydroxide. It is pale blue and soluble. Getting? See dear student, these are the reaction of ammonium, aqueous ammonium with metal salt. But now say test for ammonia gas and ammonium ion. Ammonia gas can easily be recognized by the following characteristics. What are those characteristics? First is it has a sharp characteristic odor. It turns moist red litmus to blue, moist turmeric paper brown, phenolphthalein solution pink. Getting? Now the third one, it gives a dense white fumes with conc HCl. Why? Because ammonia, when react with conc HCl, it will give ammonium chloride, dense white fume. Got? Now, when ammonia gas is passed through copper sulfur solution, blue precipitate is formed, that is copper hydroxide is formed, which change to deep blue solution being passes the gas in excess. Ammonium salts give brown color precipitate with Nessler solution. What is Nessler solution? Say Nessler's solution. This is your formula is K2HgI4. This is your Nessler reagent. It is slightly alkaline solution of potassium, mercuric iodide, made by adding KOH. Now uses of ammonia. Serious student uses, very important uses. Liquid ammonia is used as a refrigerant in ice plant. Liquid ammonia takes a lots of energy to vaporize, 5,700 calories per molecule at -33 degrees centigrade. This heat is taken from the surrounding bodies, which are consequently cooled down. Anhydrous ammonia is clear, colorless liquid, and under pressure it evaporates rapidly and produces a cooling effect. This makes ammonia a good refrigerant. All these properties are, dear student, very important one. You should have to pay attention while reading these uses of ammonia. The main refrigerant used are frozen chlorofluorocarbon, that is CFC. They deplete ozone layer and also contribute to global warming. Thus, these refrigerants are harmful to life. The chlorofluorocarbon are decomposed by ultraviolet rays, highly reactive chlorine, which is produced in the atomic form. Say CF2Cl2. Getting UV light. Then it will be CF2Cl plus Cl gas, chlorine gas. Now, the free radical chlorine reacts with ozone. This free radical chlorine reacts with ozone to give chlorine monoxide plus oxygen gas. This causes depletion of ozone. Chlorine monoxide further reacts with atomic oxygen. This chlorine monoxide reacts with atomic oxygen, then it will give chlorine gas plus oxygen gas. Again, this free radical chlorine destroys the ozone, and the process continues, thereby giving rise to ozone depletion. Ozone layer acts as a blanket in the atmosphere above 16 km height of the Earth's surface. It absorbs the harmful ultraviolet rays coming from the sun, thus protects the life on Earth. Now, advantages of ammonia as a refrigerant. What are the advantages of ammonia as a refrigerant? Serious student, I am explaining this one. Say Ammonia is environmentally compatible. It does not deplete ozone layer and does not contribute towards global warming. It has superior thermodynamic qualities. As a result, ammonia refrigerant system use less electricity. Ammonia has a recognizable odor, and so leaks are not likely to escape. Ammonia has some disadvantages. It is not compatible with copper, so it cannot be used in any system with copper pipes. Ammonia is a poisonous in high concentration, although it is easily detectable due to peculiar smell, and also being lighter than air goes up in the atmosphere, not affecting the life too much on the earth. Ammonia solution is used as an important laboratory reagent in qualitative analysis. It gives characteristic color metallic hydroxide precipitates. Aqueous ammonia emulsifies dissolved fat, grease. Aqueous ammonia emulsifies dissolved fats, grease, etc. So it is used to remove grease and perspiration stains from clothes. For cleaning tiles and windows, it is being used. Ammonia is used in the manufacture of nitrogenous fertilizer like ammonium sulfate, dihydrogen phosphate, ammonium nitrate, and urea. So when ammonia reacts with carbon dioxide at 150 degrees centigrade and 150 atmospheric pressure, urea is formed. This is the preparation of urea. How it is being produced? When ammonia reacts with carbon dioxide, the temperature is, this is your 150 atm and 150 degrees centigrade. Then this is your urea. This is the formation of urea. Explosive like ammonium nitrate. Ammonium nitrate decomposes explosively, leaving no residue behind. That is ammonium nitrate. On being heated, N2O plus H2O. Other ammonium salts such as ammonium carbonate used in dry cell and in the preparation of nitrogen gas. Say sodium nitrate plus ammonium chloride. This will give NaCl plus ammonium nitrate. Now this ammonium nitrate gives nitrogen plus water. Getting nylon and rayon and sodium cyanide, plastics, dyes, organic chemicals, explosives, and wood pulp. Sodium carbonate by solvent process. This process involves interaction of ammonia, carbon dioxide, and sodium chloride in water solution, resulting in the precipitation of sodium hydrogen carbonate. What is this? NaCl plus ammonia plus CO2 plus water. NaHCO3, sodium bicarbonate plus ammonium chloride. The sodium hydrogen carbonate is separated and ignited to obtain sodium carbonate. When this sodium bicarbonate is being ignited, it will give sodium carbonate plus water plus carbon dioxide. Getting? Serious student, read the chapter thoroughly, and what are the reactions are given here. You should have to practice those reactions, those uses, properties, and everything. Write the question answers in your class or copy, and when the school will reopen, that time I want to take the copy.